In this video, we'll be looking at some extra examples. So I'm on 3.3, extra examples. So the first one I want to look at is x squared y equals x squared minus 6x plus 9. So we want to find all those things. We're going to find the vertex, axis of symmetry, x-intercepts, and y-intercepts. Okay, so we'll find the vertex first. Vertex, we use that x equals negative b over 2a. So I'm going to have x equals negative 6 over 2 times 1. So x will equal 6 over 2. So x equals 3. I got x equals 3. Next we plug in to find our y. So we know y is going to be equal to 3 squared minus 6 times 3 plus 9. So we have y equals 9 minus 18 plus 9, y equals 0. So our vertex is 3, 0. Axis of symmetry. We know that's going to be our x-coordinate of our vertex, and we just write it as an equation, x equals 3. X-intercepts. Let's go ahead and just practice using our quadratic formula. So we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I'll plug in my values and we'll simplify. So I get x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 9 all over 2 times 1. Now I'm just simplifying, so I have x equals positive 6 plus or minus the square root of 36. Negative 6 squared is positive 36. Now I have negative 4 times 1 times 9 would be negative 36 over 2 times 1. So I get x equals 6 plus or minus square root of 0 over 2. So we get x equals 6 plus 0 over 2. And we get x equals 6 minus square root of 0 over 2. Well, this will be x equals 6 over 2, which is 3. 6 plus the square root of 0. 6 plus 0 is 6. 6 divided by 2 is 3. We're going to get the same thing over here because now I'm just doing 6 minus 0 over 2 is 3. And we got the same thing, and we knew that this was going to happen because our determinant was 0. Our discriminant was 0. The discriminant was 0, so I only have one x-intercept. So x-intercept is 3. And then our y-intercept, that's pretty straightforward because we are already in our standard form. So our y-intercept would be 9, just the c value. Okay, let's graph this and then we'll have a short discussion over what we're looking at. So I'm graphing. So I know my vertex is 3, 0. So I'll go over 3, 1, 2, right here, 3, 0. There's my vertex. Then my x-intercept is also at 3. My axis of symmetry is passing through here, and then my y-intercept is at 9. I'm just going to count by 2's, 2, 4, 6, 8, 10, so my y-intercept will be about right there. Using my axis of symmetry to help me plot a mirror point. Since I'm 3 away from my axis of symmetry, I can go 3 away again to get that mirror, that symmetrical point. We'll use that to connect our dots, like so. And so what we have here is, and this kind of like makes sense logically if we think about this. If I have this U-shaped curve, the only way that it can cross the x-axis one time is if that point is the vertex. So when there is only one x-intercept, that x-intercept must also be the vertex. It's kind of like a little bonus extra knowledge right there. And then you can imagine if we had no x-intercepts, well, we would just have like a U-shape that's up here. I could have a U-shaped kind of right here. Imagine a U-shaped up there, or I could have my rainbow shaped down below, and then there would be no x-intercepts. So I just wanted to do one more extra example so we could see what that looks like. And this is an extra example when we have one x-intercept, our discriminant equals 0, and this is what that would look like. And when our discriminant's negative, we just won't cross the x-axis at all. We'll be floating up here or floating down here. So thank you very much for watching this video, and I hope you have a great rest of your day.